We needed more power in electrification, or in the electrical motor if we only had one motor. So hence we came up with a dark matter. It features our Raxial flux technology that we patented for the cork motor, but it now has 6 phases. It's the world's first 6-phase E-motor for automotive use. Imagine a motor so small it could fit in your backpack, yet so powerful it could launch a 4-seat car faster than a Bugatti. No gears, no noise, no wasted energy, just pure controlled force. Sounds impossible, right? But that's exactly what Sweden's most secretive engineer has built. It's called dark matter, and it's about to shake the foundation of the entire electric car industry. How did Koenigsegg do it? And why are companies like Tesla and BYD suddenly watching closely? Stick with us to the end to find out. The engineer who builds the impossible. While Tesla was becoming a household name and legacy, automakers poured billions into electric dreams. One Swedish engineer ignored the entire playbook. Christian von Koenigsegg doesn't chase trends, he breaks them. He builds what others say can't be built. And when he's done, the impossible looks routine. His story doesn't start in a family garage or an engineering lab. It begins with a 5-year-old boy in Sweden who didn't just play with toys, he took them apart to understand how they worked. At 5, he made a declaration that most adults dismissed as fantasy. I'm going to make the fastest car in the world. 40 years later, he proved it. In 1994, with no investors, no factory, and no reason to believe it could work, he founded Koenigsegg Automotive, a supercar company born from obsession, not opportunity. When he unveiled the CC prototype, experts couldn't believe it was real. But it was, and it marked the start of a new kind of competition, one built on precision. That precision has created some of the most radical automotive breakthroughs in modern history. When others added gears, Koenigsegg removed them entirely with direct drive. When others made engines bigger, he shrank them and replaced camshafts with free-valve technology, software-controlled precision that redefined efficiency. While others relied on steel, Koenigsegg built carbon fiber monocoque so strong they changed crash safety standards. Every invention came from one question: why are we doing it this way? That defiance turned a small Swedish workshop into a company that makes Ferrari cautious and Bugatti nervous. From the CCR's world speed record to the Agera RS hitting 277.9 miles per hour and the Regera's gearbox-free hybrid system, Koenigsegg has never stopped pushing boundaries. Yet for Christian, speed was never the goal, it was proof of concept. So while the auto world rushed to chase electric power, Christian asked a different question: what if everything we think we know about electric motors is wrong? That single question led to years of secret development. The result was a machine that broke every rule of electric propulsion. They called it dark matter, and when they finally revealed the specifications, competitors checked their math multiple times because the numbers seemed impossible. Why dark matter means more than you think. Koenigsegg could have named their motor power core or hypervolt like everyone else, but they chose dark matter for a reason that reveals everything about what they built. In physics, dark matter is the invisible force holding galaxies together. Scientists know it exists because they can measure its effects. Galaxies rotate, stars orbit, entire cosmic structures hold their shape, but they can't see it, touch it, or directly detect it. Dark matter makes up most of the universe's mass. Yet, it remains completely hidden, influencing everything around it through pure invisible strength. Koenigsegg's motor works the same way. It's compact enough to hide in places you wouldn't expect. It runs silently, producing no engine roar and no mechanical drama. From the outside, it looks unassuming, almost ordinary, but the moment it activates, everything changes. The power-to-weight ratio tells the real story. Dark matter delivers approximately 20 horsepower per kilogram. Think about what that means. For every kilogram of motor weight, you get 20 horsepower of output. Most electric motors and production vehicles manage between 2 and 3 kilowatts per kilogram, which translates to roughly 3 to 4 horsepower per kilogram. Dark matter multiplies that standard by 5. Tesla's Model S Plaid uses 3 electric motors to achieve its performance. Each motor weighs approximately 30 kilograms and produces around 300 horsepower. That's 3 motors totaling 90 kilograms, delivering 900 horsepower combined. Dark matter produces 800 horsepower from a single unit weighing 39 kilograms. One motor does what takes Tesla 3, and does it with less than half the total weight. The Rimac Nia, which is currently one of the world's most powerful electric hypercars, uses 4 motors that, together, produce 1,914 horsepower. The combined motor weight actually exceeds 150 kilograms. Now, dark matter produces nearly half that power, but at roughly 1/4 the weight. The efficiency gap here isn't just incremental, it's generational. Take a look at the Porsche Taycan Turbo S, which is widely respected for its engineering excellence. Its motors produce a combined 750 horsepower from units weighing about 100 kilograms total. Dark matter actually exceeds that power output, while weighing 61 kilograms less. The weight savings alone could improve handling, reduce energy consumption, and allow engineers to optimize vehicle balance in ways that just weren't possible before. But, raw power numbers only tell part of the story. Dark matter's maximum rotational speed reaches 8,500 revolutions per minute. That kind of responsiveness means you get instant torque delivery across the entire rev range. No lag, no buildup, and no waiting for turbos to spool or gears to engage. You press the accelerator and full power arrives immediately, maintained consistently until you lift off. The motor's physical dimensions are honestly equally absurd. It measures 15.1 inches in diameter and 5.3 inches thick. You could actually stack 3 of them and still have less height than a standard car tire. Yet this compact package handles electrical loads that would overwhelm motors twice its size, sustained thermal stress that would just cook conventional designs, and magnetic forces powerful enough to tear lesser components apart. Now, let's compare those dimensions to typical EV motors. The Ford F-150 Lightning, which is an industrial-grade electric truck designed for hauling and towing, uses motors that are significantly larger and heavier than dark matter, yet they produce less peak torque. The Lucid Air Sapphire, a luxury performance sedan, uses 3 motors that, when combined, are larger and heavier than dark matter, while only producing comparable power. Koenigsegg isn't just improving on existing designs here. They're operating in a completely different category. These specifications really demand an explanation, and that explanation lies in technology the automotive industry simply hadn't seen before. Koenigsegg invented it. Raxial flux, the technology that, didn't exist until now. Koenigsegg didn't just build a better electric motor, they went ahead and invented an entirely new category. This new category combines 2 opposing designs into something that neither could achieve on its own. You see, electric motors have traditionally followed 2 distinct architectural approaches. Each has its own clear strengths and, of course, some unavoidable weaknesses. Understanding both of these approaches really helps explain why Koenigsegg's hybrid approach is such a fundamental breakthrough. Now, radial flux motors are the most common type. You'll find them in everything from power tools to Tesla vehicles. In these motors, the rotor spins inside the stator, with magnetic flux lines radiating outward from the central axis, kind of like spokes on a wheel. This design is mechanically simple, relatively easy to manufacture, and scales well for mass production. The drawback is size. To increase torque, you must make the motor longer, which adds weight and creates packaging challenges. Radial motors excel at high-speed operation, but struggle with torque density, producing less rotational force per unit of volume compared to other designs. Axial flux motors take a completely different approach. Instead of wrapping the stator around the rotor, axial designs place them face-to-face in parallel planes like 2 discs with magnetic forces acting parallel to the axle. This pancake-shaped configuration delivers higher torque density in a more compact form factor. The magnets and coils can be larger in diameter, creating more surface area for magnetic interaction, but axial designs have their own limitations. They're more complex to manufacture, harder to cool effectively, and typically don't handle high rotational speeds as well as radial configurations. For decades, motor designers chose one path or the other based on their priorities: radial for high-speed applications, axial for high torque needs. Koenigsegg refused to choose. They merged both approaches into what they call Raxial flux architecture, a term they coined because no existing vocabulary described what they'd created. Dark matter's Raxial design layers rare earth magnets in a configuration that generates both radial and axial magnetic forces simultaneously. The rotor and stator interact in multiple planes, channeling magnetic flux in 2 directions at once. Theoretical marine applications face similar constraints. Electric boats and watercraft need high torque for propulsion, but can't afford heavy drivetrains that raise the hull in the water and increase drag. Dark matter delivers marine-grade torque in a package light enough to mount in positions that improve rather than compromise boat dynamics. High-performance racing boats, commercial vessels, and even submarines could benefit from power units that produce this much thrust without traditional engine bulk. Industrial, robotics, and manufacturing automation require motors that run continuously without overheating, deliver precise torque control, and maintain reliability over millions of cycles. Dark matter's thermal management and efficiency characteristics make it ideal for industrial applications where downtime costs money and performance consistency matters more than peak output. Heavy lift drones for construction, logistics, and emergency services need exactly what dark matter provides: sustained high power in a weight-optimized package. Koenigsegg designed dark matter with scalability in mind from the beginning. The company already produces most components in-house, giving them complete supply chain control and the flexibility to adapt the design for different applications without relying on third-party suppliers. As production volumes increase, manufacturing costs will decrease, making the technology accessible to industries beyond automotive. Whether Koenigsegg licenses the technology, supplies motors directly to other industries, or keeps it proprietary for their own vehicles, dark matter represents a fundamental breakthrough that extends far beyond the hypercar market. The question now is, will this motor soon floor giants like Tesla and BYD, and will its technology find its way into the cars we drive every day? Drop your answer in the comments section below, subscribe and turn on notifications so you don't miss what comes next. Because if dark matter is just the beginning, the future of performance might be faster than anyone expects. Thanks for watching. See you in the next one.